Introduction, background of study and objective. This study aims to assess the health status of university students by analyzing the relationship between their weight and how often they exercise per week. Data was collected from 30 students of both genders. We aim to find out if students who weigh more tend to exercise more often. The finding will help support better health promotion and student wellness initiative on campus. For objective, to describe the gender and weight of participants. And the last one, to investigate the relationship between weight of participants and how often they exercise. Next is significance of study. Understanding how student lifestyle affect their health is essential. This study highlights how maintaining a healthy weight may improve stamina, as reflected by exercise frequency. By including gender as a factor, it also helps reveal psychological difference between males and females, especially in metabolism and physical limits. Awareness of this factor allows students to make informed their health decision and avoid pushing their bodies beyond safe limits. Early identification of unhealthy pattern can prevent negative outcomes, both physical and emotional. Overall, the study encouraged healthy lifestyle and support university in designing better health programs tailored to student real needs. Limitation of study. This study has a few limitations. Data was collected through self-administered e-questionnaire, which may include socially desirable response. The sample size was small and not fully representative of all students from different faculties or backgrounds. Although both qualitative and quantitative variables were included, other important factors affecting health were not controlled, which may influence the result. This limitation should be considered when interpreting the findings, and future research is encouraged to explore these areas for deeper insight.
Objective to analyze the relationship between weight and exercise frequency in maintaining good health. The data source is self-administered and e-questionnaire. The participant is 30 university and age around 18 to 21, 70 female and 30 male. Weight range is 42 and 85 kg. The population sample is population 30 university. The sample is same as the population sampling technique. Simple random sampling selected from research list of volunteer. Data collection method is direct observation from experiment. Variable and measurement level. Variable is gender, weight, and exercise frequency. Type of variable is qualitative and quantitative continuous. Level of measurement is nominal scale and ratio scale. This study help us explore how a person's weight and exercise habit can influence their health to maintaining their strategy. Data visualization method for the study. Pie chart. Show the percentage male versus female volunteer based on the gender distribution in the study. The second one, weight distribution histogram. Data table, weight versus number of volunteer histogram. X-axis frequency, Y-axis is weight. The third one, exercise frequency histogram. Data table is exercise day versus frequency. The histogram is X-axis exercise day, Y-axis is frequency. The fourth one, box and whisker plot for weight and exercise day separated by gender used to analyze skewness in distribution. The fifth one, scatter plot. X-axis is weight, Y-axis is exercise day. Show the relationship between weight and exercise frequency. Statistical analysis of weight and exercise day. Descriptive statistics include central tendency, mean, median, mode, dispersion, variance, standard deviation, range. The position measurement, minimum, maximum, Q1 and Q3. Distribution shape, skewness, correlation analysis, measurement, strength and direction of relationship between weight and exercise day. Result, interpret using correlation coefficient. Positive and negative, weak or strong correlation, regressive analysis. Simple linear regression, explore the relationship between two variable independent variable X weight, dependent variable Y, exercise day. Help predict how exercise day vary with weight. Regression equation, Y equal to A plus B x y, where X weight, Y exercise day, A is Y intercept, B is slope.
Hello and Assalamualaikum, my name is ARISYA binti Fauzi. So now I will show you about the result that we had collect. So from the data includes a total of 13 female and 17 male of volunteers, which is 43.3% and 56.7%. From the graph, we show you that the volunteers who participate in the study have a much heavy weight overall. The heaviest weight of the volunteer recorded that take part in the study was 85 kg with only one volunteer, and the lightest weight of the volunteer recorded that take part in the study was 42 kg with only one volunteer. From the graph, we can also identify the mode, which is 45 and 50 kg, which is both have 3 volunteers that were recorded. The skewness of the exercise per day in a week is plus 248. This indicates the overall distribution of the variable is right skewed, since the value of the skewness is at a positive. The plot shows that the median line quartile 2 is located more towards to the right. So for the descriptive analysis, from the table show, the mean value of the variable is 55.18 kg. This means that on the average, the volunteer weigh at 57.18 kg. From the median, we can interpret that 50% of the volunteer weigh less than 54.75 kg, while 50% of the volunteer weigh more than 54.75 kg. As for the mode, we can interpret that most of the volunteer weigh at 55.0 kg. The standard deviation for this variable is 11.4487, while the variance is 131.073.
Box plot of volunteer weight by gender. The overall skewness of the variable is 0.748. This means the distribution of the variable is right skewed since the value of the skewness is at positive. From the box and whisker plot in the left side, we can see that weight for both male and females is skewed to the right. It is positively skewed. The range of the variable is 43 kg. This means the difference between the largest and the smaller dataset for the weight is 43 kg. The minimum of weight is 42 kg, while the maximum is 85 kg. The first, second, and third quartiles are 48.5 kg, 54.75 kg, and 65.975 kg respectively. This implies that 25% of the volunteer weight less than 48.5 kg, and 75% of the volunteer weight more than 65.975 kg. The second quartile will be referring to the mean since the value of it are the 50% of the overall datasheet. Descriptive statistic. For the second quantitative variable, which is the days in a week of the volunteers doing exercise, the mean value for this variable is 3.33. This means that on the average, the volunteer exercise in days is 3.33. The median, we can interpret that 50% of the volunteer exercise in a week was less than 3.5 days, while 50% of the volunteer exercise in a week more than 3.5 days. As mode, we can interpret that most of the volunteer running speed is at 4 days. From this value, we can imply that the deviation of the data from the mean are much smaller, and the data will spread not much greater than the mean since the variance value is considerably small. Box and whisker. The overall skewness of the variable is 0.428. This means the distribution of the variable is right skewed since the value of the skewness is positive. From the box and whisker plot above, we can see that weight from both male and female is skewed to the right. It is positively skewed. This also implies that mode value is higher than the mean value. The range of the variable is 0.4 to 7 weeks. This means the difference between the largest and the smallest dataset for the weight is 0.4 to 7 weeks. The minimum data size is 0, while the maximum is 7 weeks. The first, second, and third quartiles are 2, 3.5, and 4.25 weeks. Respectively, this means that 25% of participants exercise less than 2 days per week, while 75% exercise more than 4.25. Correlation and regression. Based on the respective value from the table above, the regression line equation that we obtained was y equal to negative 1.07x plus 60.73. This implies that every additional time a person exercises per week, their current weight decreased by approximately 1.07 kg on average. A scatter plot was created using the data collected to illustrate the relationship between exercise frequency per week and current weight in kilograms. Scatter plot and table at the side, we can observe that there is a very weak negative linear relationship between the number of times a person exercises per week and their current weights. This is supported by the correlation value, which is r equal to 0.198, indicating a very weak correlation. The coefficient of the determination, which is r square, equals to 0.039, show that only 3.9% of the variation in current weight can be explained by exercise frequency, while the remaining 96.1% is likely influenced by other factors such as diet, metabolism, genetic, or lifestyle habits.
For conclusion, this study examined the link between student weight and how often they exercise each week. The lightest student weight 42 kg exercise 6 days a week, while the heaviest at 5 kg exercise 4 days, which show greater variation than exercise frequency, and both datasets were positively skewed. Regression analysis revealed a very weak negative relationship with only 3.9% of weight variation explained by exercise frequency. In summary, while exercise may support student well-being, other factors have a greater impact on weight. Promoting healthy lifestyle and further research into student wellness is recommended.